So this is the second video in the series where I give the same Project Euler problem to 4 different AI models and see how each of them approach it. The 4 AI models are ChatGPT, Gemini, Grok, and Claude. Same problem, same wording, but no hints. Last time Grok got it completely wrong, while the other 3 found the right answer through very different methods. This time, I want to see if the pattern holds or if something completely different happens. The problems come from Project Euler, a collection of increasingly difficult math and programming challenges. And what makes this worth watching isn't just who gets it right, is that 4 models can look at the same question and come up with completely different ways of thinking about it. The problem this time is called the number mind, which is problem 185. And if you've ever played with Wordle or Mastermind, you already understand the code of it. You're given 22 guesses of a 16-digit secret number. Next to each guess, you're told how many digits are exactly in the right position. Not which positions, just the count. So from those 22 clues, you have to figure out what is the unique 16-digit secret. The scale is what makes it hard. 16 digits means 10 quadrillion possible combinations. You obviously can't try them all. So you need to work through the constraints to cut the search space down to something a computer can actually work through. And there's one clue in particular that's incredibly useful. One of the 22 guesses has 0 correct digits. Not 1, not 2, but 0. Which means every single digit in that guess is completely wrong at that position. And immediately tells you 16 things you know are false before you've even done any searching at all. Grok went with something I genuinely didn't expect for a math problem. It used simulated annealing, which is a technique borrowed from physics where you model a system cooling down and settling into a low energy state. Instead of reasoning about the constraints directly, you start with a random 16-digit guess and measure how wrong it is across all 22 clues. And then you make small random changes, keep the ones that reduce the total error and revert the ones that don't. When you get stuck, you do a random jump to try and escape. So this is something genuinely creative about applying a physics logic to a math puzzle. It treats the whole problem as an optimization problem rather than a deduction one, which is a completely different way of seeing it. But here's the issue. Grok hardcodes a random seed of 42, which means every run gives the same sequence of random numbers and lands on the same answer. But if you change that seed, there's no guarantee that it works. So the correctness depends on one specific random sequence happening to converge. It's not a mathematical solution, it's sort of a lucky one with a fixed seed. ChatGPT went with a completely different solution, using recursive backtracking, which is the most direct approach to a problem like this. It fills in the answer position by positioning left to right, and at each step it tries each possible digit and checks whether the partial assignment is consistent with all 22 clues. The pruning is simply straightforward. As you assign each digit, you track how many of the clues' positions you've already matched. If the count for any clue exceeds the target, that path is dead. And if there aren't enough positions remaining for any clue to reach its target, that path is also dead. So what I like about this solution is it's completely transparent. Every decision point is visible, the logic follows directly from the problem statement, and there's nothing surprising about how it works. It finds the right answer every single time because there's nothing random about it. For a problem with a unique correct answer, that reliability and that understandability, clarity is actually worth something. Gemini took the same backtracking foundation as ChatGPT, but made it slightly smarter in 2 different ways. The first thing it does is, before any searching at all, it uses that 0 match clue. Since one guess has 0 correct digits, none of those digits can appear at those positions in the correct answer. So Gemini uses that idea to immediately eliminate 16 specific options from 16 positions before even the first recursive call. The second thing is a pre-computed table it calls max future, which stores each clue and each remaining position. The maximum number of matches that could still be accumulated that gets used during the search as a tighter lower bound. Instead of just asking whether there are enough positions left, it asks whether there are enough positions left where the right digit is still actually possible. That's a much stricter test and it cuts far more branches. So the result is a solver that explores dramatically fewer dead ends, reaching the same correct answer through a much smaller position of search space. It's the same approach of ChatGPT, done with a couple of more nuances and foresight. Claude looked at this at the level of the problem itself. The problem is, find a 16-digit number that for each of 22 constraints the exactly right number of positions match. That's a constraint satisfaction problem, a well-defined category with decades of research and tooling behind it. So Claude modeled it that way. It set up 16 variables, one per position, each with a domain of 0 to 9. Then for each of the 22 clues, it created a constraint saying that the number of matching positions must equal exactly the given count. Then it handed that model to the OR tools, which is Google's industrial grade constraint solver, and asked it to find a satisfying assignment. OR tools runs constraint propagation and search algorithms that have been refined for exactly this type of problem. So the model gets built, the solver runs, and the answer comes back out in 100 milliseconds. The interesting thing is, for the same instinct Gemini showed in the loss problem, when it used script for the assignment problem, recognize the shape, reach for the right tool for that shape. Applied here to something considerably harder. Now, when we see it side by side, Grok uses simulated annealing, creative but dependent on a fixed random seed and not a guaranteed different run. ChatGPT used the clean left-to-right backtracking, reliable and readable. Gemini added zero constraint elimination and a pre-computed look-ahead table that tightens the search. And Claude recognized that as a constraint satisfaction problem and used an industrial solver that handles it in 100 milliseconds. So all four found the answer 464026157 and so on, though Grok's correctness is conditional on the random seed and may not always work in every instance. Claude is the fastest and the most declarative solution. When you model a problem correctly and hand it to a solver optimized for exactly that class of problem, you obviously get results like 100 milliseconds for something that takes backtracking several minutes in pure Python. That's not a small difference, and recognizing problem types and using the right tools for them is genuinely valuable, and Gemini did it last time, Claude did it well here. But Gemini actually deserves the true credit in this case. The pre-computed look-ahead it built from scratch is not obvious. Most people who see this problem think backtrack over positions and check constraints and stop there. But Gemini went one step further, computed a tighter bound on what's still achievable from each step onward, and then used that to eliminate branches before entering them at all. That's true algorithmic thinking, not just matching a pattern to a library. ChatGPT's solution is the one you'd write if you understood the problem clearly and implemented the most straightforward approach. There's nothing wrong with it. It finds the right answer, but it's just not speed, efficient, or readable in most instances. And then Grok. The simulated annealing idea is genuinely interesting, and it is a legitimate technique for harder problems, where exact methods don't exactly scale. But for a 16 position problem with a unique answer that exact backtracking handles in seconds, a probabilistic method that depends on a specific random seed is simply the wrong fit. Correct with a seed 42, but not reliably correct in general, and in any setting that distinction actually matters.